We studied confirmation bias in data visualizations, asking participants to solve a hard reasoning problem. We tested if specific designs would lead to less biased reasoning strategies. Participants were often tempted to use simple heuristics, only comparing a few data points. With a table, participants were more likely to solve it correctly, using a complex reasoning strategy of comparing two ratios.
The average value of this line appears to be much higher than it actually is. We found this effect across two pre-registered experiments. We also showed that it can be reduced by switching to dot encoding and modeled using an encoding with points along the line. Understanding and predicting this bias has implications for designers and tool builders, as it affects one of the most popular visualization types.
How do you think scientists and practitioners visually represent gender? What visual variables and language do they use? Through an 11-year review, we showed that color is the most frequent visual variable used to distinguish gender. In particular, visualization designers tend to use the red color to represent women and the blue color to represent men. In the paper, we also present results related to the language most used to distinguish gender between female-male or woman-man.
Machine learning models often learn and exacerbate dataset bias, including in healthcare, finance, and the criminal justice domains. However, this bias can erode users' trust. We study how humans perceive and act on such bias. We found that women trust fairer models more often than men do. Participants value fairness more when the model is explained using text and a bar chart, and explicit annotations have a greater impact on people's perception of model fairness compared to showing its past performance.
What do we learn from visualization experiments and what are the values of them? Our framework answers this question by comparing a behavior agent to a rational agent. Our framework can be used for pre-experimental analysis, where we can bound the value of information, and also for post-experimental analysis, where we can analyze errors in information extraction. We apply our framework to award-winning papers and find previously overlooked issues.
If you saw a visualization like this while you were reading the news, how would you decide whether to trust it? Would you trust it because it's clear and easy to read? Or maybe you're just a trusting person. We propose a framework that outlines different factors, both cognitive and affective, that can impact how we form trust in data visualizations. We apply this framework to a large study that looks at the relationship between trust and visual variables such as complexity.